I hope you've been enjoying the course so far. It's essential that you follow the steps that we recommended in the beginning of the course. If there's anything you're stuck at or you do not understand, please make sure that you review the video a couple times, go do some research on your own, ask on the Hackers Academy forum, and if all that doesn't work, drop us an email. Send me an email personally and I will make sure to respond. So far we covered what the internet is about, what are the components of the internet and how does it work. We talked about what IP addresses are, the difference between public IP addresses and private IP addresses. And we explained that these are unique numerical addresses for every computer or server on the internet. We explained what's the difference between a regular computer and a server, and the fact that a server would have a service running on it, such as a web service or an email service, and that we can communicate with this service to send and retrieve data. We also mentioned that these services would have port numbers assigned to them. In the following section, we're going to be discussing how do these services work, on what basis. So get ready, because things are beginning to get more technical now. In this section, we cover what I like to call interview questions. If you are going to begin your career into ethical hacking, as a junior penetration tester or as a junior ethical hacker, you are required to understand certain concepts, without which it's very difficult for you to land a job. Whoever is conducting your interview wants to know that you have a very good understanding of certain concepts, and these are the concepts that are going to follow in this section to the end of the course. We're going to be covering what packets and protocols are, what port scanning, what vulnerability scanning, what exploitation is, and so on. Now keep in mind, like we said earlier, that there is no way we can cover everything in one course, or in multiple courses for that matter. There is a lot that one can learn. However, what I'm trying to give you here is the stepping stone into the world of ethical hacking. So once you know what a packet is and how does it look like, and what a protocol is and how does it look like, instead of me trying to teach you about every single protocol that's out there, which is an impossible task to do, what I would invite you to do is that you would go and study about all the common protocols. In this section, we're going to be talking about a few main ones that you definitely, absolutely should know about, that you cannot start without knowing about. Remember, this is the hacking course for beginners. So we're going to be helping you to begin in the following sections. And then later on, you want to go and expand your knowledge on your own. Let us begin by talking about packets. Between computers, data isn't sent whole. Whether you are communicating with another computer, another server, another mobile, whatever data is being sent between them wouldn't be sent as whole. When we say data, we mean pretty much anything that's being communicated. Pictures, videos, documents, emails, etc. The sending computer would break the data down into what we call packets, and the receiving computer on the other end would reassemble these packets and see and read the data. For example, if the computer on the left-hand side wants to send a message to the other computer saying, "Hi, how are you?" it will break it down into different sections or different packets. Hi, how are you? And it will send them in that order. The receiving computer on the other end will reassemble these packets and then read the message as a whole, understanding that it's a question asking, "Hi, how are you?" in order for it to respond. How is this broken down and how is it reassembled on the other side? This is what protocols is about. Because there are some questions that we need to be asking ourselves right now. The first obvious question is, how do we make sure that the data is being sent to the correct recipient? Do I just blast the data out on the internet and hope that the recipient will get it? How do I know that it's being sent to the correct port? We mentioned earlier that some servers would be providing more than one service, for example, email and web. How would I know that the receiving server is getting the email on the email port and not on a wrong port? How would I know that my data's integrity is intact? How would I know that, for example, my email is being sent in the correct manner and we're not losing some words or some pictures or some quality of the pictures in our email attachments? How would I know that the recipient is able to restructure the data in a correct sequence? To answer these questions and more, we rely on protocols. In the world of networking, protocols are a set of rules dictating how to communicate. For example, when you're communicating over the phone, it's the protocol that you pick up the phone, say hello first and then initiate the conversation. You wouldn't say hello before you pick up the phone. You definitely wouldn't initiate the conversation without answering the phone. It just wouldn't work. Similarly, in the world of networking, this is what protocols dictate and mandate. Now, for the internet to work, we would need a number of protocols stacked on top of each other. What do I mean by that? Going with answering the phone example. In some countries, for example, it's customary and it's the protocol to start with a courteous conversation, asking about the other person, how they are, how their family is, how they've been, and so on. You wouldn't just pick up the phone and say, hey, how's it going? I want this. That would be incredibly rude in some countries. In other countries, maybe that works. So there are different protocols depending on where you are and who you're communicating with. The sequence, for example, would be: first, you hear the phone ring. 2, you pick up the phone. 3, you would answer the phone, saying hi. 4, the other person would respond by asking a number of questions. How are you? How you been? How's the family? And so on. And then 5, the communication channel is open to exchange any kind of communication. The Internet Protocol, or the IP, which is the protocol that we mentioned very earlier on in the course, is one protocol that has a simple job of labeling communication with a source and a destination address. We've seen what IP addresses look like. These numbers have the only purpose of taking care of the recipient and the sender. So the Internet Protocol has the job of just delivering stuff. It doesn't worry about the order of delivery. It doesn't worry about whether it's being delivered in the correct order. All it does is that it knows who the address is and who the recipient is, and it just delivers. So if we look at an IP packet, this is what it would look like. This is an oversimplified IP packet, obviously. We're going to be looking at actual packets in a moment. But for now, an IP packet would look something like this. It has a source address of the sender, it has the destination address of the recipient, and some other kind of data that we really don't care about at this point in time. Another protocol that is very common on the internet and in networking is the Transmission Control Protocol, or TCP in short. And this is the protocol that handles the correctness of the order of the packets being sent, whether a packet has an error in it, or whether a packet has been lost or not. So for example, if I'm sending the hi, how are you message from one computer to another, the Internet Protocol would look after who the sender is and who the recipient is, and it would make sure that the message has been delivered to the correct recipient. The TCP protocol would make sure that the message is being sent in the correct order. So the hi is being delivered before the how, and not the other way around. And it will also make sure that the packets are correct, the content of the packets is correct. So for example, the how is being delivered as a how, not as a who. And then lastly, it will check for lost packets. So if a packet has been lost on the way, has been dropped for whatever reason, it will ensure that the packet is being resent. For this to happen, the communication needs to be initiated in what we know as the TCP handshake. The initiation of the phone call, when you hear the phone ring, you pick it up and you say hello. This is very similar to what a TCP handshake is. The TCP handshake works as such. The sender, whoever wants to initiate communication, will send one packet called the SYN packet. This is the synchronization packet, which is basically a packet that says, hi, I would like to talk to you. The recipient, on the other end, will respond with a SYN ACK packet, which is an acknowledgement of the synchronization message. It's similar to a response saying, yes, I hear you, let's talk. And then the initiating end will send one more packet, which is the acknowledgement packet saying, I acknowledge that you can hear me, now we can start the communication. So when it comes to phone conversations, it's similar to you hearing the phone ring. This is the SYN packet. Somebody is asking to talk to you. You pick up the phone and you say, hi, this is you acknowledging that you heard the phone ring and you answered it. You're ready to talk. And then the other end would respond by saying, hey, this is them acknowledging that they can hear you too on the phone, and then the communication can begin. And here's what a TCP packet would look like. It's a little bit more complicated than the IP packet. All the IP packet had was a source address and a destination address. The TCP packet, on the other hand, has more information. It has the source port and the destination port. So if I'm talking to a web server, we mentioned earlier that it's very likely I'm going to be talking to port 80, which is the standard port for web. So I would know that in my TCP packet, the destination port would be 80. The source port, however, would be something special to me, which is the port where my data is leaving from. It doesn't have to be port 80, it could be any port. The third field that you see here is the flags. What we mentioned earlier in the TCP handshake, the SYN, SYN-ACK, and ACK, these are called flags. And you can see these on the TCP packets. And then there's a whole bunch of other stuff that we don't care much about at this point in time. So remember when we mentioned that for the internet to work, we would need multiple protocols stacked on top of each other? This is what a TCP IP packet would look like. If you are in the world of networking or IT, you would have heard the term TCP IP so many times. And if you get into the world of ethical hacking, or IT for that matter, you cannot go one day without talking or hearing about TCP IP. TCP IP is short for TCP over IP, and it basically is a packet of TCP stacked on the packet of IP. So in this example, we have a packet of IP taking care of the source address and the destination address. I'm communicating to a web server, so I know that I am the source address and the destination address would be, in that case, let's say hackersacademy.com. The IP packet's job is done. On top of it, I would know that I'm communicating from X port to port 80 on the Hackers Academy server. And if I'm initiating the conversation, the flag on the TCP packet would be the SYN packet. So what is the web traffic exactly? There is the IP packet taking care of the source address, the destination address. There's the TCP packet taking care of the data sequence, the error correction, and the drop packets. But what is the web data? The web data is in a third protocol called the Hypertext Transfer Protocol, the HTTP. HTTP is the basis of data communication on the internet, on the World Wide Web. This is how we transfer graphics, video, audio, text, and links. And it works similar to TCP. So for example, if I'm trying to retrieve the logo from hackersacademy.com, I would send what we know as the GET request, an HTTP GET request. I will ask the server to give me the logo. The message that I would send would tell the server that I want to get the logo. The server will respond with an acknowledgement message saying, I acknowledge your request, and then the server will send another message saying, here's the logo. So now an HTTP request would look something like this. You have the IP with the source address and destination address, my source address and the destination address of hackersacademy.com. You have the TCP taking care of the correctness and the sequence of the data and so on, with the source port from my machine to the destination port of 80 on the Hackers Academy. You would also have the flags of the TCP packet depending on which part of the communication we're on. And then you would have the HTTP stuff that we just mentioned. For example, the logo from hackersacademy.com website. Alright, so enough theory. Let's have a look at what packets actually look like. Download the packet capture file and open it using Wireshark. I've pre-captured some packets for you that I'm going to walk you through. So now you can see what a TCP packet looks like, what an IP packet looks like, and how the HTTP communication looks like. If you have correctly installed Wireshark, all you have to do is, after you download the packet capture file, double-click on it and it will open automatically in Wireshark. There are a total of 7 packets in this capture, and we're going to walk through them one by one. First, let's talk about the interface of Wireshark. On the left-hand side, you have the sequence of the packets. So you can see that this is the first packet where the communication capture started, and this is the last one, number 7, where I stopped the capture. This is the time where the packets were captured. You have the source IP address and the destination IP address. You have the protocol of the packet captured, the length of the packet, and some more information. So let's click on the first packet and expand it. Skipping to the third field, you can see that this is an Internet Protocol version 4 packet. So this is an IP packet with the source IP address of 10.10.192.92. This is my machine's IP address. And the destination is 94.201.252.25. This is the IP address of Google. This is the Transmission Control Protocol field, or the TCP field. The TCP communication is leaving my machine from the source port of 63379 to the destination port of 80. So now I can tell that I'm trying to talk to this IP address, the Google's IP address, on port 80, which means that I'm talking to a web service. If you go down a little bit, you will see that there's a SYN flag being set. This is the first packet of the TCP three-way handshake. So here I'm initiating the conversation with the Google server. Let's have a look at the second packet. Now the source has changed. So now the communication source is Google's IP address, and I am the destination in this case. The packet I'm receiving is a TCP packet with the SYN ACK flag set on. Let's have a closer look. This is the IP information, the source and the destination, which we already know by now. And this is the TCP information. So now the source port is 80 and the destination port is 63379. The information between the first packet and the second packet has now been inverted. In the first packet, number 1, the source was me, the destination was Google. The source port was my source port, and the destination was also Google's at port 80. Because I was initiating the conversation, it was me who started the conversation. And then Google responded. So now the source is Google, and the destination is myself. And the response came from port 80, which I started communicating with, to the destination port on my machine. You can see now that in the second packet, the TCP flags SYN ACK are set. So Google has acknowledged my SYN packet and is ready to start communication. The third packet I send is the last in the TCP handshake, which we expect to have the ACK flag on. So now again, I'm communicating with Google, sending a TCP packet to port 80 with the ACK flag being set as on. So now, my TCP handshake is done and the conversation is ready to begin. I have my TCP stacked on top of IP. Now it's time to use the HTTP. The first thing I'm asking Google to do is give me an image, the Google logo. And I do this by using the HTTP protocol GET request. Remember what we talked about? In HTTP, we have GET requests that we can use to retrieve information from the web. And here what I'm asking for this logo, which lives on Google's server under the images directory, branding, and so on. So let's have a closer look. The first thing you'll notice here that there's another additional field. The previous packets, if we look back at it, had the IP and the TCP. Now we have the IP, on top of it TCP is stacked, and on top of it is the HTTP. Let's open this and have a closer look. This is the HTTP GET request. So the server will know that I'm asking for the following URL, images/branding/Google logo, and so on. I'm retrieving or I'm asking for this logo. So how would Google respond for my request? We see that in the next packet. Notice that there is no longer an HTTP field here. All what's happening is that Google now is responding with an ACK. It's saying, I acknowledge your request and I'm going to send you the logo. And then it follows it with an HTTP packet of its own. So now the HTTP communication has been initiated as well, and it's happening, to which my machine will respond with a TCP ACK packet. Let's summarize. I want to retrieve an image file, a logo file from google.com. The first thing I do is I initiate the conversation. I give Google's phone a call, and this happens through the TCP SYN packet. Google hears the phone ringing and acknowledges my call and responds by a SYN ACK. Google picks up the phone and responds by saying hi. I respond by saying hello. So I acknowledge Google's acknowledgement, and in the third packet, I respond to Google's response. The first three packets are the TCP three-way handshake: SYN, SYN ACK, ACK. After the initiation of the conversation, it's time for me now to ask for what I want, and I send the HTTP GET request using the Hypertext Transfer Protocol. Google acknowledges my request and continues talking HTTP to me. and then I acknowledge Google's HTTP communication. Here's your mission for this section. We saw the flags on the TCP three-way handshake, the SYN flag, SYN-ACK flag, and the ACK flag. Find out what other flags TCP uses, and what are they used for. Then using Wireshark, capture traffic from hackersacademy.com. Try to identify the source and destination IP addresses. And try to identify the source and the destination port you're communicating from and to.